All right, so order of operations. This is the order in which you simplify an expression. You've got to do it in this order to simplify it correctly. This is all a review. So how many do it for the saying, please excuse my dear Aunt Sally, raise your hand. Okay, awesome. So remember, this is just a saying that helps us remember, it's an acronym or whatever, that helps us remember the order in which you simplify. So P stands for parentheses, right? If you have parentheses, you'll simplify inside the parentheses first. E is for exponent. So you'll simplify your exponent next. And then M is for multiplication. D is for division. So in this order is how you'll simplify. Now, fun fact for you, even though my comes before dear, so multiplication goes before division, they actually go hand in hand. So you can divide before you multiply, and you can multiply before you divide. It doesn't matter. They go hand in hand. They're equal in order. Does that make sense? Okay. Aunt Sally, add and subtract. Once again, you can add first and then subtract, or you can subtract first and add. They go hand in hand. However, you will want to simplify in the parentheses, then simplify exponents, then multiplication and division, and then addition and subtraction. So let's just start practicing. My problem is the same as yours on the notes page. Here we go. So we're going to simplify this using order of operations. Parentheses comes first, so we need to simplify inside here, right? Okay, so this is 4 cubed. 4 cubed, and then we have minus 10 divided by 2. So let's go. Exponents comes next, right? So let's simplify. 4 cubed, remember that means 4 times 4 times 4. Did anyone bring a calculator today? Just curious, get them out. Awesome, 4 cubed. Make sure you're making sure you're ready for 4 cubed. Okay, so we have 64, and then look, we have minus 10 divided by 2. Should we subtract 10 and then divide by 2? No, divide first. So really, we have 64 minus 5, right? So we get 59. There's our answer. Boom. Here we go. Next problem. 1B, make sure you ask questions if you have any. Here we go. First. So really, we have 4 times 6 plus 2 is 8, right? Then we have minus 6, minus 1. I'm showing my work. Multiplication comes first, right? So we have 32, and then we have minus 6, minus 1. So we can go ahead and do that, and we get 25. Questions? Pretty simple, right? We're starting out really basic. For a reminder, get our brains in math. Yeah, you could distribute that in. That would be fine as well. Good question. Okay, next one. 1C, guys, pay attention. You're going to be able to practice in a second and chit-chat then. So we have inside our parentheses, we're going to want to simplify that. So we have 4 minus 10. Let's put that in parentheses. And then we have divided by 5, right? So division comes first. So really we have 4 minus 2, which is 2. Questions? Okay, continuing onward. Here we go. Let's simplify this. 9 over 2 times negative 1 minus 1 cubed. So on top, 9, nothing we can do with that for right now. On bottom, we have inside our parentheses a negative 1. Well, we don't need to simplify anything there, right? Okay, it's just negative 1. So 2 times negative 1 is negative. So we have negative 2. Then we have minus 1 cubed. So 1 cubed is just 1. So we have negative 2 minus 1. So on top we have a 9. On bottom we have negative 2 minus 1. Think about it. That's negative 2 and then minus 1 more is negative 3. Yeah? Yeah. So 9 divided by negative 3 is negative 3. Yo, we all good? Okay. What about this one? Should we go for it together? Simplify in your parentheses first, guys. So inside here we have 1 squared, right? 1 squared, which is 1. And then we have plus negative 6. We're simplifying in our parentheses. Now I'm going to show you something. All that stuff's divided by 3, right? Yeah. So we've got to actually simplify that top part first, because all of it's divided by 3. So on top right there, 4 minus negative 2. When we subtract a negative, it becomes positive. So on top we have 6, right? So what's 6 divided by 3? So we have 2 minus 5 in our parentheses. Negative 3. Now remember that was in parentheses. So don't we have minus negative 3 right there? Because it was still minus, Inside our parentheses, we got -3. Okay, so we have minus -3. So when now we can change those negatives to positive, and now adding and subtracting goes in any order here. So what do we get here? -6 plus 1 is -5. -5 plus 3 is -2. Questions? Okay. Okay, I just want to remind you, I'm going to change this one just to show you. Do you see this absolute value sign? I'm not even going to go through this one. Absolute values just change any value inside to be positive. So see how this is absolute value 2? Positive 2. If it was absolute value of -2, it would be positive 2. What I saw first hour from my secondary 3 students is they said -2 squared is -4. Wrong-go. -2 squared means -2 times -2, which is positive 4. Get it right. Okay, awesome. Go, 1 through 6. On the practice, you're doing 1 through 6 on your practice worksheet. Switch, not your note sheet, do the practice 1 through 6. Go. So, I'm going to remind you, listen up, back to your notes page. It's not worth it to keep working. You'll be lost on the next one. So, the step to solve a linear equation. Our first step is to combine all like terms on each side of the equation. Like terms, so like 2x plus x. Don't say that's 2x squared. What's 2 apples plus 1 apple? How many apples? 3. 3 apples. The apple part doesn't change. So we have 2x plus x is 2x, which is equal to 10, right? Does everybody see what I mean when I say combine like terms on each side of the equation? Second step, isolate the variable by combining all like variables. Now you can't just, so looking at this, guys, 2x minus 1 is equal to 3x. Do you see how we have 2 x's? You don't just magically float the x's together. You can't do that. You have to use inverses to combine those x's. So look, we have a positive 2x, right? Yeah. We're going to apply the inverse, meaning we're going to subtract 2x to both sides of the equation to combine our x's. Now look, technically that becomes 0, right? So -1 is equal to 1x, right? Everybody? Just saying, this is really basic. Third, isolate the variable completely by applying the proper inverse. So we have 2x is equal to 10, so we divide both sides by 2. Now I just want to remind you what inverses do. They undo each other. Multiplication undoes division, and division undoes multiplication. So we're going to get our variable alone by applying inverses. Addition undoes subtraction, subtraction undoes addition. So look up here. This is hopefully going to be pretty easy for you. If I said solve for x, isn't x being multiplied by 3? Yeah. What undoes multiplication? Division, right? So what do we divide both sides by 3? Right, everybody? Now look over here. I always tell students, and when they first come into secondary 3, that they look at this and say, well, what the heck? Look, think about it. X divided by 3 is equal to 1. I said x divided by 3, what undoes division? Multiplication. So look, I'm going to multiply both sides by 3. Now look, 3 over 3 is 1, right? We get x is equal to 3. Do you guys see what I did there? Okay, addition, we would subtract 2 from both sides of the equation. X is equal to -2. Undoing subtraction, we'd add 1. Okay, we're all good with inverses. Okay, here we go. First example. Solve the equation. So the first thing I'm going to do, now we can solve this like 10 different ways. Notice something. We have 2 times all that stuff. Does everybody see that? So we're going to multiply that 2 into all that stuff in parentheses. So we have -12x, and then 2 was also multiplied there. So -8, right? And we have -8x is equal to 168. Now we're going to combine all of our x's over here. So we have -12x minus 8 more x's is -20x's. So -20x minus 8 is equal to 168. And the reason we're doing all this is just because we've got to get our brains using math again, yeah? +8, you're right. +8, what the heck am I doing? So we have -12, so we have -12x plus 8 minus 8x still though, right? So we combine our x's, and we have -20x, but this is +8, right? Right? Sorry about that. Good catch. Who caught that again? Back over here. Thank you. So now we're solving for x, getting x alone. So we'd subtract 8 from both sides. Isolate the variable. So we have -20x is equal to 160. Divide both sides by negative 20, right? Are we isolating the variable?
Oh, yes.
Right? When you multiply, to undo multiplication, don't we divide? So x is equal to negative, what is it? Yep, negative 8. Very good. Questions? Problem, guys, here we go. Next example. We're solving for b. Look up here. Negative 5 times all that stuff, right? So let's distribute quickly. We have negative 5. Negative 5 times positive 7 b's is negative 35 b's, which is equal to negative 5 minus 5 b's, yeah? Now over here, there's nothing more to combine, nothing more to combine. So now we want to combine our b's, but you can't just float them together, so you're going to use inverses. So what I'm going to do is add 35b to both sides. So over here on the left, those out to be 0, we have negative 5 is equal to negative 5, and then we have plus 30b's, yeah? Isolate b, we're trying to get b alone, so won't we add 5? So we have 0 is equal to 30b's. Now to get b alone, what undoes multiplication? So we divide both sides by 30. What's 0 divided by 30? 0. B equals 0. There's our solution. Questions? It's all making sense? Right? This should not be new to you. If it is, then you probably shouldn't be in the class. I mean, it's been a long summer, but if it's like, I've never seen that before, that's when you might want to think about transfer. All right, so I'm not going to do that one. How about this one? Hey, I want you to notice something. Everybody look, this is going to help you. We have a fraction on this side and a fraction on this side. We're going to solve this one by cross multiplication. I don't want to have to deal with fractions. However, we could deal with fractions, but I don't want to have to deal with fractions. So we're going to get rid of the fractions. So what I'm going to do is I'm going to multiply both sides by, isn't this 5 being divided? What undoes division? So I'm going to technically multiply both sides by 5. Now look, we have all of this stuff being multiplied by 5. It needs to be put in parentheses. Do you all understand why? With both entire sides by 5. And then those 5's divide out. Now do you see how we don't have a fraction anymore? Because 5 over 5 is 1, right? You guys see that? Now I'm going to multiply both sides by 4. Now look, 4 over 4 divides out to be 1. Do you see how I got rid of our fractions? That's called cross multiplication. So we have 5 times 3x plus 5, and then is equal to 4x times 4. So now I'm going to solve by distributing. So we have 15x. What? Well, our 4 is divided out, right? Yeah, we multiplied this side by 4. Yeah. So we have plus 25 is equal to 16x's, yeah? Now we can't just float those x's together. Let's get our x's by inverses together. So we'll subtract 15x from both sides. 25 is equal to x, or x is equal to 25. Same thing, right? Question. Okay, one more. This one, 2f. Solve the equation. So we're going to simplify this. Right now we have fractions, but the first thing I want to point out, don't we have 4 over 2? Which is 2 over 1, right? Don't 4 and 2 both divide by 2. 4 divides by 2 and becomes 2. 2 divided by 2 becomes a 1. The reason I write it like that is because if this 2 was on top and 4 is on bottom, it would have been 1 over 2, right? Okay. And now I don't want to deal with fractions, so I'm going to cross multiply. So I'm going to technically multiply both sides by x plus 1. I always put, when you have two terms, put it in parentheses. Now look, x plus 1 over x plus 1 divides out. We're not dealing with fractions anymore. So we have 2 times x plus 3 on the left. And on the right, we have 3 times x plus 1. Do not forget parentheses when multiplying something. Let's distribute. So we have 2x plus 6 is equal to 3x plus 3. Let's solve for x. Don't float your x's together. Use inverses. So we have 6 is equal to x plus 3, subtract 3, right? Get x alone. right? So x is 3. Are we following? We're all good. You're ready to practice. Okay, you're going to be doing 7 through 12. Go, go, go. Properties of exponents. You guys should have become experts at this in secondary math too. However, it's been a long summer and some of you are still not experts. So let's try and talk some vocab. Everybody look up here. We've got to fly through this. So watch. Okay? This is the base. This is the exponent. Does everybody understand that? So if I say the base, you're looking at this. If I say exponent, you're looking at this. Do you all understand that? On the notes, flip to the second page. Yeah, we're skipping past that other stuff. Okay, here we go. So the properties of exponent sum. We're going to review some property rules. The zero property, and this is already on there, so you don't even need to take notes. You can just watch. The zero property. Any base raised to the 0 power is equal to 1. Any base raised to the 0 power is equal to 1. Now notice the whole base becomes a 1. You all see that? So what's 12 to the 0 power? What's 5 to the base to the 0 power? Now let me tell you a common mistake. People say any base raised to the 0 power is 1. And they'll say, oh, so 1. Do you see how I made the exponent 1? That's wrong. It's the whole base becomes 1. Do you guys understand the difference? Okay, sweet. Next thing, when you multiply the same base, you will add the exponents. So I have a little song I sing, and I'll get to it in a minute. But when you multiply the same base, you add your exponents. So this would be 8 to the 4 plus 3, right? 8 to the 7th. Now here's why. Watch so that you understand. 8 to the 4th is 1, 2, 3, 4 8. 8 to the 3rd is 1, 2, 3. How many A's do we have? 7. That's why that property works. Okay, now look over here. 2a squared times 3a. Now here's a common mistake. People think 2 is connected to a squared and 3 is connected to a. That's not true. This is all multiplication. This is just 2 times a squared times 3 times a. So we can reorder this in any order. So I'm going to put like variables and like bases by each other. So I'm reordering it. 2 times 3 times a squared times a. What's the exponent on a? Don't say 0. 1. Do you guys understand how I can reorder it? Simplify it in sections. What's 2 times 3? 6a, and when you multiply, you add. A cubed. Are we all comfortable? So this one, we'll reorder it. 5 times 2 times a squared times a to the 9th. So we simplify it in sections. That's 10a to the 11th. Yeah? All of you are going to see a problem with the property of exponents on an ACT that you will take at the end of the mid year. Okay, when you divide, then you subtract. So if you divide the same base, you're going to subtract your exponents. You always subtract the top from the bottom. That's the important part. Top from the bottom. A to the 7 minus 2 equals a to the 5th. No matter what, we subtract the top from the bottom. So let's look at this example. 6 over 2. We just simplify that. 3 over 1, yeah? Now look, it's a to the 10th, and then it's divided by a to the negative 1. When you divide, you subtract. So it's 10 minus, and now look at the bottom. What is it? Negative 1. Do you see why it's minus and negative, people? Yep. When we subtract a negative, it becomes positive. So we have 3. Now this is gone, right? We took care of that one, that exponent. So we have 3a to the 11th. Question. Okay. Raise a power to a power and you multiply the powers. Raise a power to another power. Do you see how we're raising a power to a power? So you multiply. So this will be a to the 6th. Hey, let me sing the song for you. This is only for properties of exponents. It goes like this. When you multiply, you add. When you divide, then you subtract. Raise a power to a power and you multiply. Okay? Let's all sing it. Especially you, since you're going to be a singer, you said when you grow up. You're not going to college, you said. Ready? When you multiply, you add. Let's all sing it. I'm going to make you all. Ready? When you multiply, you add. When you divide, then you subtract. Raise a power to a power and you multiply. All right, here we go. Last thing, if you have a negative exponent, it's not acceptable to have a negative exponent in your final answer. So how do you fix that? Watch carefully. Okay. Guys, remember when I'm talking, you don't talk, it's rude? Yeah. To fix a negative exponent, you flip it over a fraction and that will make it a positive exponent. So a to the negative 2, to make that a positive power, because it's not acceptable to have that as a final answer, we flip it over a fraction. So we bring it to the bottom and now it's positive 2. Left on top wasn't nothing. There was always a 1 there. So we have 1 over a squared. That is how you would properly write a to the negative 2. You will see something like that on your ACT promise. Okay, looking at this one, we have 3 over a to the negative 4th. This answer would not be an acceptable final answer. We flip negative the base over a fraction. So we have a 3 on top and a to the positive 4. Does everybody understand? Okay, looking at this one, we will distribute that negative 1 through. So we have 1 to the negative 1 over a to the negative 1. Don't they both have negative exponents? Yes? So we're going to fix this one by flipping it down over the fraction and fix this one by flipping it up over the fraction. On top we have a to the first. Bottom, you guys, I wasn't kidding when I said like when I'm teaching you don't talk. It's rude. So don't. Or you're going to be in a different teacher's class in like 2 weeks. I will kick you out. Okay, any questions? Okay, moving on. We've got to look at the difference between these two. Do you see how 2 and a are both raised to the negative 2 power? So we've got to fix both of those things. So we draw our line, we're going to take it, flip it over a fraction. On top, there's a 1 left. On bottom, we have 2a, and they're both raised to the positive 2, right?
Yes.
Do you guys understand that? Yeah. So if we simplify that, that's 1 over 2 squared a squared, which is 1 over 4a squared, yeah? Okay, and last one. 2 times a to the negative 3. This is what people do. They'll say, oh, 2 is connected, so we're going to flip all that. Wrong. Isn't this 2 to the positive 1 power?
Yes.
2 to the positive 1 is not a negative exponent, so we only flip the part that has the negative exponent. So this would be 2 over a cubed. This should not be new to you guys. This you should have learned last year. Are we all comfortable? Okay, let's do some harder examples here. Let's start out with this one. This one's probably the hardest one. It's weird. Really different. So, it's multiplication, so we can reorder it. So we have 2 times 2 to the r times r squared. Now look, are those the same base? No. So you can't combine those two. But look right here. Don't we have a 2 to the first times 2 to the r? Same base, right? No, you don't multiply the base part. That's what the common error is. The base stays the same. When you multiply the same base, what do you do with the exponents? Add. So aren't we going to just be adding 1 plus r? So this, we can put into 1, 2 raised to the 1 plus r. When you multiply, you add. And then we have times r squared. There's nothing more you can do with that. Not the same base, so you can't put them together. That one was the trickiest one. And we started out with it. Okay, next one. 3b, nah, we've already done one like that. What about this one? You can do that one, right? Pretty easy. Okay, let's go for this one. Take my suggestion. Simplify the top, then simplify the bottom, and then simplify the whole thing. Here we go. Focusing on the top, let's simplify it. When you multiply, so we have 2x to the negative 6 on top, right? And on bottom, we are raising powers to a power, so we multiply. Okay, and there's a few different ways we could simplify this. You multiply. So we have x to the negative 8 times x to the 6, right? Now look, when you multiply, so on top we have 2x to the negative 6. On bottom we have x to the negative 2, right? Are we adding the bottom exponent? Okay, now looking at it, we would say, can this simplify even more? When you divide the same base, you subtract the exponents, right? Let's be really careful. So we have the top, negative 6, then we're subtracting, and now what is the bottom? Negative 2. So now we have 2x to the, subtracting negative becomes positive. What's our answer? Negative 4. Now we draw our line, flip the piece that we need to, x to the positive 4. So our answer is 2 over x to the positive 4. That's not that bad. Good question. Why don't we take 2 with it? Is 2 connected to x to the negative 4? No, just by multiplication, right? This is 2 to the positive 1, which isn't a negative exponent. Good question. Okay. Should we do... Oh, I wanted to do this. Let's see. Yeah, let's do this one. So, look, guys. Raising powers to a power. You multiply, right? So we have k to the negative 2 times. Look, isn't all this stuff being raised to the 0 power? So that becomes 1. And on bottom, we have 4 times k to the 4th. Isn't that a 1? When you multiply, you... So we have 4k to the 5th. So now let's continue to simplify. The top minus the bottom if they're the same base. So negative 2 minus 5. We took care of that. Now 4 still on bottom, right? I'm going to draw my line. 4 still on bottom. So k to the negative 2 minus 5 is... Don't we need to now flip our negative exponent over a fraction? What's anything times 1? Just itself, right? Yeah. No, that's a good question. It's a really good question. I never even thought to say that, so that was a good question. So we're going to pull this to the bottom. We have k to the positive 7. What was left on top? 1. So our final answer is 1 over 4k to the 7. Okay. All right, what I want us to do is a problem off your practice real quick. Everybody go to problem number... On the homework, everybody go to problem number 24. Does that one look good? Okay, here we go, and then I'll let you practice. Here we go, number 24. I'm going to write that down real quick. Okay, here we go. Let's simplify it. Take my suggestion, simplify the top, then simplify the bottom, then simplify the whole thing. Isn't x to the 0 1? What about y to the 0? Now let's keep simplifying. Isn't this multiplication on top? So we have 2 times 2, which is 4. We have y's to the negative 2. Do we have any other y's? Y to 0, well, that went to 1, right? So we have y to the negative 2, x to the negative 4. Can't combine those. We've simplified the top. On bottom, raise power to a power and you multiply. So remember this will distribute to both of these. So we have y to the negative 3, x to the positive 3, right? Negative 1 times negative 3.
Yeah. Positive 3. Yeah.
True means no, so yes or no?
Yeah.
We're good?
Yes.
Okay, now we'll simplify the whole thing. When you divide them, you subtract. So we're going to have negative 2 minus 3, right?
Yeah.
Minus negative 3 is what I meant to say.
Yeah.
Minus negative 3. Does everybody see why?
Yeah.
Because we take the top minus the bottom. When you divide them, you subtract. So it's the top negative 2 minus the bottom, which was negative 3. Somebody said no. Does that make sense? Because it's the top, which is negative 2, and then minus the bottom exponent, which was negative 3. That's why it's minus negative 3. Okay, so we have negative 4 minus 3, because x is the same base. So now we took care of that. So we have 4y to the 1. What's negative 4 minus 3? No, negative 4, subtract 3 more. Negative 7. Now we're going to fix anything. Oh, that's an x, right? Sorry about that. That's an x. And now we draw our line, flip our fraction. Flip whatever we need to over the fraction. Isn't that the only piece? So we have 4y all over x to the positive 7. You've got it, guys. You've got it. Think critically. Go. Up through 24 is what's due by next time. Up through 24 on the worksheet. This video will be posted if you need to watch it again, maybe go slower, rewind it, watch the examples again. Okay, 1 through 24 is due by next time. You should be working on that till the bell rings. Do not put anything away. Check with me as you go.